Hey friends. We're going to take a look at our next note, which is kind of part two of our last note. In our last note, we talked about the extreme value theorem and we talked about finding local max and mins. But finding local max and mins was also finding where the original function was increasing and decreasing, because when we plotted those roots or those critical numbers on a number line and we figured out, oh, the derivative is positive in this section, a positive derivative meant the function's increasing. So the reason I'm calling this sort of part two is because there's actually nothing further new compared to part one, with the exception of now we're also going to state the intervals of increasing or decreasing of a function. Okay, so the note is called determining intervals on which a function is increasing or decreasing. It is lesson 3 in our unit 5, which is the 4th chapter of differentiation that we've been going through. Okay, so increasing and decreasing functions. Consider the following function of y equals f of x. Now, with respect to the derivatives, the domain for this function is split into 3 intervals, and this is what the 3 intervals would look like, okay? So this pink interval that I've given you so far would be from negative infinity to negative 5 over 2. Here, the derivative will be greater than 0, so all tangent lines will have positive slopes. And that tells us that the original function is increasing. So when the derivative is greater than 0, when the derivative is positive, the original function is increasing. Now, you should be able to, with your amazing brain, realize that the next section is going to go from there to there. Okay, and I have that as a blue section here. So it's from negative 5 over 2 to 3 over 4. Here, the derivative will be less than 0. All the tangent lines will have negative slopes. And that tells us because the derivative is negative, the function itself is decreasing. The y values are getting smaller and smaller. Then from 3 over 4 to positive infinity, we're back to the derivative being positive. The tangent lines will all have positive slopes, and the function will be increasing. Now, at those critical numbers, the derivative equals 0, and we already know from our last lesson that it could also be that the derivative doesn't exist, but that's not this case. In this case, they would be 0. So at negative 5 over 2 and at 3 over 4, the derivative is 0 and the tangent line is horizontal. At that point, the function is neither increasing nor decreasing, okay? It's in the middle of changing. Okay, so in general, if the derivative is less than 0, the function is decreasing. If the derivative is greater than 0, the function is increasing. And if the derivative is 0 itself, the original function, f of x, is neither increasing nor decreasing. Okay. These results are a direct consequence of the definitions of increasing and decreasing in the mean value theorem. Okay, so we'll just have a quick connection to the mean value theorem here. F is increasing whenever x2 is greater than x1, implies that f of x2 would have to be greater than f of x1. Bigger inputs mean bigger outputs. So let's just unpack that for a sec. Suppose that x2 is greater than x1 and the derivative at x is 0. The mean value theorem states there exists a point at x equals c where the derivative of f at c would be the slope of the difference between x2 and x1. So f of x2 minus f of x1 over x2 minus x1, right? That's the mean value, or the derivative of c essentially would be parallel to the slope formed from connecting x2 to x1. Now, if the left-hand side is positive and the denominator is positive, then the numerator has to be positive, which means the output for x2 has to be bigger than the output for x1. Okay, All right. The derivative of f is given by derivative of f of x is 3x squared minus 12x. On what intervals is f of x increasing? Now I'm just going to hide myself for 1 second so you can get the question. Now, take note, I've given you the derivative, so I don't have to take the derivative. It's already given to me. I just have to set that equal to 0 or doesn't exist. This is a polynomial function, so it will exist for all values of x. I'm just looking at when it equals 0 then. I factor the 3x out and I get 0 and 4 as critical numbers. I go right to plotting 0 and 4 on a number line. This should all feel exactly like it just felt with our last lesson. So if you went right into this next lesson, you can understand why I was suggesting you should glue these guys together, okay? So to the left of 0, we'll try -1, maybe -2, plug it in and see what happens. You end up with positive to the left of 0, negative in between 0 and 4, and after 4 or greater than 4, I'm back to being positive. So the derivative is positive. The function is increasing from -infinity to 0. The derivative is then negative, which means the function is decreasing from 0 to 4. And then we're back to increasing from 4 to infinity. So we say the function is increasing on the interval -infinity to 0 in union with 4 to infinity. Please take note that I'm using curved brackets, not square brackets, because I can't be infinity. And I'm actually at 0 and at 4, neither increasing nor decreasing, right? And my reason for this statement is because the derivative is positive. It's greater than 0. Okay, the graph of the derivative of f of x is shown. On what intervals is f of x increasing? Okay, so similar conversation. It's just now we're looking at a graph instead, but we are looking at the graph of the derivative. And so we know that we are looking for when the derivative is positive. So the derivative is positive from there down and from 4 to the right, right? The derivative is positive here and positive here. And so when the derivative is positive, the original function would have been increasing. So I'm going to say from -infinity to 0 in union with 4 to infinity. Okay, -infinity to 0 in union with 4 to infinity. I'm just going to hide myself there so everybody can see the question. And perfect. Okay, and then we could also look at it from a table point of view. The function f is differentiable for all real numbers, and its derivative has exactly 2 zeros. Selected values of the derivative of x are shown in the table. What are the intervals of x where f of x is increasing? Okay, well, it says I'm looking for when my my critical numbers, which are when the derivative is 0. So I can see the derivative is 0 there, and the derivative is 0 there. Okay. On this section here, I see that my derivative is positive. This section here, I see my derivative is negative. This section here, I see my derivative is positive again. Okay, so whether I'm looking at it from a number line perspective, or whether I'm looking at it from the graph, or whether I'm looking at it from a table of values, it's all very much the same sort of conversation that you're having. Okay, so f of x is increasing on the interval -infinity to 0 in union with 4 to infinity because the derivative of f of x is positive. Okay, and one more time, I'm just going to hide my face while I clear that drawing so that everybody gets a chance to see the question. Okay, awesome. Make sure you justify why the function is increasing or decreasing. So that's where we're saying because the derivative is greater than 0 or because the derivative is less than 0. Okay. Okay, the derivative of f is given by the following. Determine the intervals for which the function is increasing. Okay, so I already have the derivative. I'm going to set the derivative equal to 0. This is going to give me sine of x equals -3, which I would want you to say is bogus because nothing will exist there. This is going to give me x is 0. This is going to give me x is 0 as well because e to the 0 is 1 and 1 minus 1 will give me my 0. And then this will give me out a 5. So I've got 0 and 5 as critical numbers. I'm then going to plot those on a number line. I'm just going to hide my face while I do that. Plot those on a number line and then test each region. Okay. So there's my number line. To the left of 0, in between 0 and 5, and to the right of 0. You're testing those into the derivative to see whether you get out a positive or negative answer. And then it's that positive or negative answer that's telling us whether the function is increasing if the derivative is positive or decreasing if the derivative is negative. I end up with negative, positive, negative. So I know I'm increasing. The question only asked for the increasing. So I'm increasing from 0 to 5. Okay, so the function is increasing on the interval 0 to 5 because the derivative at that moment is positive. Okay. Awesome. Okay, the function g and its derivative are shown in the graph below. Determine the intervals for which the function is decreasing. Now, again, I'll just hide myself for 1 second, and that way you can all get a picture of the question. Now, if we're looking for the function to decrease, we know that the derivative has to be negative. So the derivative is negative here, which would be from 0 to 4. Okay, so see how when the derivative is negative, from 0 to 4, 0 to 4, my function is decreasing that whole time. Okay. So the function is decreasing on the interval 0 to 4 because the derivative is negative. Okay. Awesome. Okay, given the graph of the derivative shown below, on which intervals is f increasing, justify your answer. Okay, so this is the derivative. I'm looking for when the original function is increasing. Well, I know that the original function will increase when the derivative is positive. So I know from -6 to 2, the derivative is positive. And then from 2 to what? 2, 3, 4, 5 will also be positive. Okay. So I'm going to say the function is increasing on the interval -6 to -2 in union with 2 to 5 because the derivative is positive. Okay. All right, this one definitely wasn't as long as part 1. That concludes our time together as far as talking about increasing and decreasing. This actually leads us into the first derivative test, which will be the next conversation we have. But we'll save that for another day. So for now, this is the same homework I gave you on the last lesson if you're following sequentially. The 5.2 and 5.3 are connected. It's one practice time for both. Okay, so give this a shot. Get yourself all feeling good about increasing and decreasing, local max and mins, absolute max and mins, critical numbers, Fermat's theorem, all of that good stuff. And if you have any questions, please make sure you're connecting with me. You guys got this. Take care.